right, I'm talking now. All right, thank you. So when you have the square root ones, these radical equations, you want to get the radical part along. Then how do I get rid of the radical? Square both sides, yeah. So when I square both sides, I get x minus 10 on the left and 25 on the right. Then all I have to do is what? Add the 10, right? So you get 35. Remember, we're supposed to check these radical ones too. But it'll work. It won't give me a 0 because 35 minus 10 is 25 and the square root is 5, right? So it works out. But you should check them. All right, number 2, when we have these fractional exponents or rational exponents they're called, we got to get the x part alone, just like we always do. So we're going to add 31 and divide by 4. Some of us forgot to divide by 4. So 108 divided by 4 is 27. So we get to this point. Remember, we want to know what x equals, not what x to the 3/4 equals. So how do we get rid of that 3/4? Close. We're not actually multiplying by 4/3. We're raising it to the 4/3 power, right? So you got to do caret, not just times. So don't forget to hit the caret. All right, you're raising it to that reciprocal power. Morning. Candygrams?
Maybe plural. I've got them in order here. All right. Autumn?
She's not here.
Oh, we'll leave it.
Leave it there for tomorrow.
Yeah. Mary. Come on up.
Is that from James?
Probably.
Yeah. Does she get the pick? Coach
Coach
Mattingly.
Mattingly. All right. Hey. No.
That's from Gavin, isn't it? Thanks, Gavin.
Sweet.
Yeah. Well,
I knew you loved me, Gavin. Thank you. All right, so remember and that's a mistake some of us made when we did these, all right, is we just said 27 times 4/3 instead of 27 raised to the 4/3 power, which is the reciprocal of 3/4, right? So we get 81. There was something else we had to do for those. You guys remember? In the beginning, we were supposed to look at this to see if it was odd or even. Okay? What kind is that? What's 3/4? Is that an odd or an even number? Odd. Okay? So we don't have to worry about when it's even. You guys remember what we had to do when it was even? Anybody? Nobody remembers? Not even Haynes? If it was even, our original exponent to start, okay, if that would have been 4/3 to start, then we would have used 3/4, right, to finish it up. Then we have to put plus or minus in our answer, okay? But this one wasn't. It was odd, so we didn't have to do that, right? But that was one of the things we had to do when we did this type of problem. So maybe on the exam, it'll be an even one. So look, maybe write that. So even exponent to start, plus or minus in your answer. All right, this one, solve and graph. These graphs, 19, 20, and 21, are number line graphs, okay? When we have a graph with one variable, it's a number line graph. When we have an x and a y, then we do our x, y axis stuff, okay? Griffin. The numerator of the original exponent. Okay? So since it was a 3, that's odd, but we didn't have to do that. All right, so this one you just solve like you would normally do if it was equals. So get the x's together and the constants together. So the x's cancel, and the 17's cancel. So I get negative, not 22, sorry. I was adding 5 and 17. That's negative 12, right? Is greater than 3x. Divide by 3, so I get negative 4 is greater than x. So it doesn't have to be, usually I give a number to the left and the right of the number we get on my number line. You don't have to do a bunch. So do I put a solid dot or a circle at negative 4? Why circle? Doesn't have the equal to, right? Good. Remember, the dot means we're including that number. We're not including the negative 4. Now this says negative 4 is bigger than x, right? That's a greater than symbol. So is negative 4 bigger than negative 5 or negative 3? Bigger than negative 5. So it goes this way when we graph it. Okay? Michael?
Greater than negative 4 the other way?
No, it says negative 4 is bigger than x. Right? If I flipped it and put the x on the left, then it says x is less than negative 4. That's still this way, right? Okay. Yeah. Yeah, x is less than negative 4 is the same as negative 4 is bigger than x. That's what I just said. All right? We got absolute value for 20. Whenever we see absolute value, how many problems do we have? 2 problems. All right, did we remember that? You okay, Michael? Trying to hurt me?
On your hand. You think I did that, dude? Yes. No.
All right, so the 2 problems, 4x minus 1 greater than 11, or 4x minus 1, and you have to change the inequality symbol to less than negative 11. So you got to change the 11 and the inequality symbol. The one we did earlier was equals. All we did was change it to the negative, right? So we do everything the same now. Add 1 and divide by 4. So what's 12 divided by 4? 3. Here we add 1, which is negative 10. And what's negative 10 divided by 4? Nobody? Negative 2.5, right? All right, so again, we're supposed to solve and graph. So 3 is over here. Negative 2.5 would be over here. Are they dots or circles? Circles, because no equal to. All right, it says x is bigger than 3, so the ones to the right of 3 are bigger than it. And it says x is less than negative 2.5, so the left of negative 2.5 are the ones that are less than. Okay? Questions? All right. 21 is a quadratic inequality, so I would just factor. Are there factors of positive 8 that add up to 6? 4 and 2, right? So what are we call these critical values that we're finding. What are my critical values? Negative 4 and negative 2, right? What makes those 0? All right? So when we graph these, okay, first of all, circles again, because no equal to. Not solid dots. What did we do to figure out where we graphed? we had to pick three numbers, right? You cut your number line into three sections. So we need to check -5, -3, and I always pick 0 whenever I can pick it. But you could use -1. You can pick any numbers you want, just so they're in those sections. All right? So then we pick those numbers and put them in the original problem. So what's -5 squared plus 6 times -5 plus 8? Well, that's 25 minus 30 plus 8, which is -5 plus 8. That's a +3. All right? Is +3 less than 0? No. So would I draw an arrow towards -5? No. Okay? When I put -3 in, and again, I put it in the original problem. Let's see if that's true. I get 9 minus 18 plus 8. 9 minus 18 is a -9 plus 8 is a -1. Is that less than 0? Yeah. So I connect those. Then when you put 0 in, it's really easy because that's 0 and this is 0 plus 8. Is 8 less than 0? No. So I would not draw an arrow that way. Okay? So that's how we figure out where to draw our arrows or if we need to connect the two circles. Okay? That coming back to us? Questions?
No.
All right. Couple more. All right. Remember, direct variations. You know, our basic direct is y equals k times x. We do multiplication. Remember, when you see the word varies, there's a constant variation in the problem. That's why the k comes up. All right. When we do inverse, it was divided by k divided by x. Okay. Joint was another one, but that was multiplication of a couple things. At least two. All right, but it was multiplication. All right, so we're supposed to write an equation that expresses the relationship between the variables and use the given data to solve for k. So when you see t varies directly, t varies, t equals k, because you saw the word varies. All right, directly means times. So I put times, and then it says the cube of r. How do I write that?
R cubed.
Yeah, r to the third. Everybody wants to put a 2 there all the time because you're thinking squared for some reason. Remember, squared is to the second, cubed is to the third. Then it says and inversely, so we also have division. So just put it over for division, write it as a fraction. The square root of s. So use your square root symbol, not your s squared symbol. All right? And then you're supposed to put in the numbers they give you. So t is 12 when r is 6 and s is 0.16. Okay? Well, 6 cubed is 216, and the square root of 0.16 is 0.4. Okay? So how do I move the 0.4? Multiply. All right? And when I multiply 0.4 times 12, I think it's 4.8. How do I move the 216? Divide, right? And that gives me what? I got 0.02 repeating.
Yes.
The 2 repeats. The fraction is 1 over 45. So either way was fine. Okay? So all you had to do was solve for k. Sometimes they would tell us to find t when, then they would say when r was 5 and s was 0.25 or something like that. But you didn't have to do the second part. Okay, for the last one, some of you were doing what we did not too long ago. Try to find the equation of the line that goes through the 2 points. That's not what it's asking, all right? It's asking for distance between the 2 points and midpoint. So on your little, note card, you should put the distance formula and the midpoint formula, okay? Distance formula is this. Subtract the x's and square them, plus subtract the y's and square them. And then midpoint is a point, and you add the x's and divide by 2 for the x value, and you add the y's. Oops, did I put mine? All right? So look at the differences. Where we made mistakes on midpoint is we would subtract them instead of add them. And then sometimes on distance, we would mix our x's and y's together. So, put those two formulas in correctly on your note cards you're allowed to use. Both sides you can use of that note card. And when you plug your numbers in, what do you guys get for distance? Square root of what? Anybody? Nobody has it? I thought some of you had it yesterday when you brought it to me. 65, right? 8.1 is the decimal. And then the midpoint, when you plug your numbers in, was 1/2 for the x and 9 for the y. All right, any questions? Anybody need to see all the work? Are we okay with plugging in? All right. We good? Any questions, 1723? All right, so today's assignment is the rest of it, 24 to 30. Okay? So work on that. When you get it done, show me to get your 5. And then we'll go over it tomorrow. We'll be ready after tomorrow. Should be.